In this lesson, we are going to graph quadratic functions, and this time we're going to graph them in intercept form. We're also going to practice writing quadratic functions that are not in standard form and put them into standard form. First, some reminders. When we are graphing in intercept form, we want to remember the form of the equation, which is y equals a, the leading coefficient, times x minus p and x minus q, where p and q are our x-intercepts. Those are the points that are crossing the x-axis. These are also called solutions, zeros, or roots. To find the vertex, once we know the 2 points where our parabola is crossing the x-axis, we simply add those two together and divide by 2 to find the very middle, or where our parabola would bend in half. That is the x value of our vertex, and then we would substitute that back into our quadratic function to find the y-coordinate of our vertex. Let's do some practicing. Here is our first equation. Y equals 2, x minus 3, x plus 1. So the first thing that we're going to do is to find our x-intercepts. Our x-intercepts are at the points p and q, and remember the general form is x minus p, x minus q. So the minus is part of the formula, so p is actually at 3, so our first coordinate will be at 3, 0. And this is plus 1. In order to change that to a plus, it must be a minus 1 for the q. So those are our two x-intercepts. So if I were to graph those, remember that's where we're crossing the x-axis at 3, 0 and negative 1, 0. You actually could, by counting, find what's directly in the middle to find the vertex, at least the x-coordinate of the vertex, and our axis of symmetry. Or, if you remember and want to do it mathematically, you simply add the two numbers together. 3 plus negative 1 is 2, and divide that by 2, so the x part of our vertex is at 1. To find the y part of the vertex, we simply plug it back into our original quadratic function. 1 minus 3 is negative 2, and 1 plus 1 is 2. And then we multiply all of these together. The leading coefficient 2 times negative 2 is negative 4, and negative 4 times 2 is at negative 8. So our vertex is at 1, negative 8. Taking a look at our leading coefficient, which is at a positive 2, we know that our parabola opens up. Since the number is larger, we are going to know that our parabola is narrower. And since it opens up, we know that our vertex is our minimum point. From there, we have to write our axis of symmetry. Our axis of symmetry is the line that divides our parabola in half. It's the vertical line, and it passes right through the vertex. To write the equation of our vertical line, we have x equals, the x part of our vertex is positive 1. Lastly, we have a choice. We could make a table to find a couple of other points, or again, we can use our parent function to find other points. So if we make our table, we have our x and our f of x. Remembering we have our 0, 1, 2, 0 squared is 0, 1 squared is 1, and 2 squared is 4. And then we use our leading coefficient times our f of x to find where our new parabola would be located. Our leading coefficient is 2, so 2 times 0 is 0, 2 times 1 is 2, and 2 times 4 is 8. Our vertex now becomes our new origin, which is at the 0, 0 mark. And then we use the directions. For x, we're going to go over 1 and up 2. I'll reflect that point to the other side of my parabola. And then from our vertex, we're going to go to the right 2 and up 8. And those just happen to be our x-intercepts. So now we will draw in our parabola. Let's try another example. First, we're going to look for our x-intercepts. Our first intercept, we have just a value of x, which would mean that originally it would be x minus 0. So the first intercept would be at 0, 0, and our second intercept, x minus 4, is going to be at the point 4, 0. So we can graph our two intercepts at 0, 0 and at 4, 0. Again, to find the x part of our vertex, we could count to find the middle, or we can simply add them together and divide by 2 to find the center of our intercepts, which is the x-coordinate of our vertex. 0 plus 4 is 4, divided by 2 is 2. The x value of my vertex is going to be at 2. Then we're going to take the 2 and substitute into our quadratic function to find the y value of our vertex. 2 minus 4 is at negative 2, and then we have 2 for our x value. So we have 2 times 2, which is 4, times negative 2, which is at negative 8. So we're at the point 2, negative 8. Taking a look at our leading coefficient, which is a positive 2, we know that our parabola opens up. Because it opens up, we know that our vertex is at our minimum point. Our axis of symmetry is our vertical line that divides our parabola in half, which passes through the origin. So the vertical line is written as x equals, in this case, positive 2. Again, we could make a table to pick random points to plug them in for the x values, or we can use our parent function to find other values for our parabola. So, recalling the part of our parent function, we have 0, 1, and 4. And now we're going to take a, our leading coefficient, times our f of x, which would be 2 times 0, 2 times 1, and 2 times 4. Our vertex becomes our new origin. So from the vertex, we're going to go over 1 and up 2, going to our point of reflection on the other side of our axis of symmetry. And from here, if we go over 2 and up 8, we are at our x-intercepts. We draw in the parabola. Now we're going to take a look at how would we write a quadratic function in standard form when it's written in one of our other forms. It's quite easy to do. We need to remember how to multiply together two binomials. If you remember, we're going to do the FOIL method. First, we'll multiply the binomials together, and then we'll multiply at the end our product by 1/2. So when we FOIL, remember we take the first term times the first term, x times x, which is x squared. The outside terms multiplied together, x times negative 4, which would be negative 4x. We're going to multiply the inside terms. Negative 6 times x is negative 6x. And we're going to multiply the last terms together. Negative 6 times negative 4, which is a positive 24. Before we multiply everything by 1/2, I suggest we combine like terms together. So we have x squared minus 10x plus 24. Lastly, we're going to multiply our entire product by 1/2, so we have our equation written in standard form. 1/2 x squared, half of negative 10 would be negative 5x, and half of 24 would be 12. So to write an equation that is in intercept form, in standard form, first multiply the binomials together, combining like terms, and then if there is a leading coefficient, multiply that through. Next, we have our equation, which is written in vertex form. So if you recall that when we have the quantity being squared, that means that we actually have two binomials that we're going to multiply together. And then when we are done multiplying the binomials together, we'll multiply by the leading coefficient of -4, and at the very end we'll add the 2 on, following the order of operations. So first, -4 times, and we're going to again FOIL, so we're going to take x times x, which is x squared, x times -7, which is -7x, -7 times x, which is -7x, and -7 times -7, which is a +49. We'll combine like terms before we multiply by -4. So we have x squared minus 14x plus 49. Now we will distribute the -4. So we have -4x squared -4 times -14 is a +56x. -4 times 49 would be a -196, and then we'll add our +2. So when we combine like terms, we're going to have -4x squared plus 56x, and then -196 plus 2 will be -194. This is taking our quadratic function that is written in vertex form and writing it into standard form. So let's review. We worked today on intercept form, y equals a, x minus p, x minus q, where p and q are our x-intercepts. Next, using the x-intercepts, by adding them together and dividing by 2, we can find the x portion of our vertex, then substituting that into our equation to find the y value. After that, we can find other points by using our parent function. And lastly, we rewrote quadratic functions that were either intercept form or vertex form and put them into standard form, which is y equals ax squared plus bx plus c. Please continue by doing the reflection.